Hello everyone, welcome to this session. In the last session, we talked about the parametric model. So in this session, we will talk about a non-parametric model and use a simple example in this category to explain it. So what are the non-parametric models? So in contrast to parametric models, in this kind of method, we don't assume there is a known form of the model. So for example, we don't assume there is a linear relation, right? So we don't assume any form of the model. And the algorithm have to learn from the data itself. So for example, there are many types of machine learning method belongs to non-parametric models. So for example, the support vector machine, the k-nearest neighbor, which we will talk about very soon. Now we will introduce a typical non-parametric machine learning method, KNN, k-nearest neighbors. So this KNN is a type of supervised learning. We can use it for both classification and regression. So KNN is a lazy learning method. So for lazy learning, this is special. It means that this doesn't have a specialized training phase, but the training and the classification or regression, they happen at the same time. So later you will see how it works. Also, KNN is non-parametric. We don't assume any form of mapping function. And KNN is widely used in machine learning. So for example, give you a few examples, the handwriting recognition, the facial recognition, text categorization. So in these applications, KNN have a very good performance. So now let's see how KNN works, right? So we have several steps. First, we choose a value of k. So this k is this k. So maybe 3n, 5n, 10n, this is a number of k, right? Then we calculate the distance of the query data of each of the example data. So what are they? So the example data are the existing data set. The query data is what we want to predict, right? So now we have the query data and we have the existing data. We can calculate the distance between the query data and each of the existing data. So in this way, the result is a set of distances, right? So we call it similarities. Then we will sort this distance in ascending order. Now after this sorting, we can select the k-nearest neighbors of the query data to make decisions. The decision is made by majority vote, right? So we assign the class to the query data based on the most frequent class of the k-neighbors, right? So these four steps are a bit abstract. So let's see a real example to explain. So now we have two categories, category A and category B, right? So we can see the data here, category A is here, category B is here, right? Now there is a query data. We call it X1, right? X1, this is new. And my question is that which category does X1 belong to? Class A or class B? Right, this is a classification problem, right? So then let's see, using the four steps, how KNN works. Step 1, choose a value of k. So now I say, okay, k equals to 5. Randomly choose 1 in this example. So I calculate the distance of the query data x1 of each example data in category A and category B, right? So we can use a distance, we can use a Euclidean distance, right? So here we can see given xy, this is Euclidean distance. Then step 3, now we get all the distance, right? We want to find the 5 nearest neighbor of the x1. So we can see x1 is here. What are the 5 nearest neighbors? Here. This is the 5 nearest neighbors, right? Then step 4, majority vote. We can see that which category does it belong to? So 3 votes category A, 2 votes category B. So the conclusion is that x1 belongs to category A. So quite straightforward process, and we get the conclusion, right? This point x1 belongs to category A. Okay, so remember just now we set the k equals to 5, right? This is what I randomly set. So if consider what about if I use a different k? Now let's try one, right? If I say k equals to 3, then k equals to 5, we can see the 5 nearest point here. That will make the decision, right? So if k equals to 3, then what will happen? We can see we need to find the 3 nearest neighbor of x1, right? So we can see it's here. So now that 2 volt category B and 1 volt category A. So in this case, right, the 3 nearest neighbors, the x1 belongs to category B, an opposite conclusion, right? So this tells us needs to be pay attention to the value of k. So how to select the value of k? So for example, k equals to 3, k equals to 5. So k, we call it a hyperparameter of kn. So this is preset and is very important. As we can see, when k equals to 3 and k equals to 5, the result is different. So therefore, we need to choose an optimal value of k. So this process, we call it a hyperparameter tuning. So this is a terminology, right, in machine learning model. And for kn, there are several rule of thumbs of selecting the k. So now let's see what are they. So first of all, k should not be too small or too large, both not good. So when k is too small, the noise will play a big role, and this will influence the decision. Just as we have said, k equals to 3, k equals to 5. This provides us different solutions, right? Different conclusions. Also, k should not be too large, because when k is too large, we include not useful information as its neighbors, but it's not its neighbor, right? So also k should be an odd number, because if we use an even number, maybe the number of votes of category A and category B, they are the same. Then how to make the decision, right? And also the domain knowledge sometimes plays a role to choose the optimal value of k. Well, these are the 3 rules, but given down these 3 rules of thumb, but we still do not know how to set k, right? So there is a concrete one, we call it the square root method. So normally we set k to be the square root of the number of samples in the example data set. So this provides you a reference, right? Okay, so that's all for this session. Thank you very much. Bye-bye.